time enough in a day.
I just started the recording, guys.
That's fine. I don't have enough time in the day to go to the Zoom and then download it to YouTube. I just don't have enough time to do that reliably.
Right.
Well, there was a big piece of it where there was just nothing, just waiting, and then there was another piece where GPT started swearing and.
Well, if hey Thomas, in regards to the VIG, record it, and I would suggest just put it out there. And Suresh, if you want to go back through it, you're going to have to go through the dull parts. Okay. In particular, we put the HBRC General in the HBRC YouTube. And right now there's an issue where nobody has the password to the damn HBRC YouTube. So, we're trying to get that moved over. Yeah. Somehow Chris Myers is able to get into it, but he doesn't understand why he has rights. Somebody long ago gave him the rights. But again, it just takes time to do these things. And man, there's just not enough time in a day.
I have a question about the recording, because I came back and I noticed you guys are recording. And as a presenter in these, if I show like a YouTube video that's not of my own creation in one of these, what are the issues around that, or a web page or whatever?
Well, it depends if you put it on YouTube.
It's on the web. It's on YouTube.
Are these do these go up to YouTube, the recordings directly?
You're saving to Zoom right now. What we do at the HBRC is we do our presentation. And again, this is a presentation, so, it's worth recording it. Whereas a discussion group, there's a lot of dead space in there. And so, there's that. Although, Martin, you do presentations, and it's worth, saving. I respect what Suresh is saying. But from where I sit, again, I got so many things going. I just don't have time in a day to be moving these hundreds of megabytes from here to there. And if I did it, I would be putting it on my YouTube, which I don't mind doing, because we're actually using my Zoom right now, which again, I don't mind doing. That's what it's for.
Well, tonight wasn't really intended to be a big presentation type thing. I actually was just bringing some things to spur some discussion. And I think there will be some stuff toward the second half that's, around kinematics. It's a little more presentation oriented.
2 weeks ago, you had quite a presentation from what I understand.
Yeah.
Yeah, that one. And I think
guys,
I think there'll be a big one in a month.
Guys, if I may answer the other question, if we do have somebody else's video, or we have some music playing, any of which is copyrighted, they can ding whose ever account this goes on. If it goes on the HBRC, they can ding it. They can threaten to close it down, the whole 9 yards. Most of the time, I've been doing this for a long time, they say, remove this part and you're good. And you can go in and click, I'll remove that part. And you go click, 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 and then it's removed, and then your video is fine. But that's typically what has happened with me in the past.
So all I had tonight that wasn't of my own creation was I wanted to just show a short video of Baxter doing something. So do you want to just pause when we get to that point?
Can I pause it? I don't even know if I can. Yes, there's a pause. Yes. Yeah, just let me know and I'll pause it.
So
actually, Martin, since you're running this, I'm going to make you the host.
I don't know if I can talk and chew gum though.
I'm going to make you the co-host for what it's worth, just in case I fall off the planet or something,
Okay.
If I had to go to the bathroom like I did last time, and then everybody didn't know what to do because Thomas wasn't there, he was in the bathroom.
What is Baxter? Who makes Baxter? I should know this.
That's Rodney Brooks.
Okay.
Carnegie Mellon, he's like he makes the little ones, and he makes some of the driving ones.
Faster, cheaper, better.
Okay, Martin, you're the co-host.
Okay. All right. Well,
that means you can do anything I can do, which includes pausing the video and cutting people off.
I doubt there's a problem with showing Rodney Brooks and Baxter. That's academic stuff.
Yeah, I wouldn't think that it would bother anybody. I just wanted to ask, since we were crossing the Rubicon of recording.
Yeah.
So one
If-
more question.
Yeah.
Sorry to stop you, Martin, and Thomas here, right? So is the process that you're trying to record, and is it intended to go to the YouTube location, or is it intended to be kept in some location so that we can access it for the SIG group? Because, the presentation, however you all decide here, right? So are you guys intending it to publish it somewhere? If not, is it going to be just a private link that you can say, share that link to me and I can just download it and watch it or something like that? What do you
It would
suggest?
it would be on YouTube.
So what is the channel on YouTube that it goes to? HPRC?
Well, it's not going anywhere currently. The
Yeah.
HPRC has a channel and I have a channel. I mean, if I was going to put something out, I would put it on my channel.
So
That reminds me, Camp, what do I do with this other video? How do I get it on the HPRC's YouTube channel?
Getting on HPRC, we'll need to work that out. Otherwise, I would put it on my YouTube channel. I don't really care. It's like, here's the VIG SIG, video, and people can go there if they want to.
All right.
Like I was saying originally, when Joe was advocating for, the video, a lot of these discussion groups are just blank space. Like right now, I think we've spent, 15 minutes talking about
Right.
nothing, right?
Yeah.
Yeah.
All right. Well, I'll get together with you offline then, and we'll figure it out, Cam.
yeah,
Yeah.
even if it's just a link that you can share with me, so that I can just download and review it, that is fine too. However you prefer. Cam, did we lose you? Maybe.
Camp's frozen in time.
Yeah.
Camp, we see a frozen Camp and no audio.
He looks shocked.
He is. We're shocking him all the time.
Okay, well, we should probably get started.
Yeah, let's sally forth, Morton.
Yeah, so thank you, everybody, for coming. And this is one of our less presentation-oriented evenings. So I do have material, but I do not care at all whether we get this material in now or in a future session. So the intention is to have some useful discussion about some things, spirited, what have you, spur some ideas. And I've been in a process of working on kinematics for the last, I'd say, 6 weeks or a month or so. And yeah, I guess it's only been about a month. So, and I don't anticipate a lot of that coming together in terms of like inverse kinematics for another month. So I'm thinking in the coming meetings that fall on my night, we'll end up getting into a lot more stuff on that in future ones. So, so what I have tonight, just to kind of kick things off a little bit, is I was looking on Hugging Face at just to try to catch up on what some of the new models are. Let me see if I can share screen before we get too deep in this. Here we are. Okay. Can you guys see my screen?
Oh, yeah.
Okay. And which one do you see, just so I can be sure? Do you see a evolution matrix?
Yeah.
Okay. All right. So what this is, and this is not all inclusive, this is just some kind of core skills on the path of having an evolved robot that's verbal. And we've touched on a lot of these different skills on these different meetings. And so what I brought up, I just kind of like people to have a concept of how all these pieces fit together and where they are in the big picture, because I think it's a big forest and it's easy to get lost in it sometimes. But we've talked about obviously robots have sensors and actuators, and we're not going to get into that tonight. We've talked a little bit about memory systems. All of these are just prerequisites to do anything useful. And we are the VIG, so we're obviously going to have a verbal system. We got into SPACY and lemmas and how to determine intent and all that kind of stuff. I don't think we've talked about that probably near enough, but that's for another night. But assuming that you have something, if you're building something and you have some concept of these pieces, then you progress on down, and at some point you start dealing, once you have a verbal system, you start being able to deal with commands. And commands come in all different shapes and sizes, of just one-line commands, multi-line, hierarchical. And we've touched on that, and we're going to touch on it again, but I'm going to kind of flip the script tonight, and we're going to start with the end in sight. We're going to start with some end outcomes and then work back from it, because otherwise we never get through, on a bottoms up approach, how we do all this. But in the midst of all this, we've also talked about using some pre-trained models. So if I blow that out a little bit, within that, there's 3 or 4 major categories, and we're the VIG, so we've been concentrating on the verbal. And so really, I think and correct me if I'm wrong, but if I think about all the meetings that we've had, we've really concentrated on 2 different types. I would say 95%. And I think that's mostly warranted, but what I want to do tonight is actually expand that out, the scope of what our toolbox is. So we've talked about dialogue models quite a bit. And like, if you're an acrobat doing flips and trying to catch somebody and all that kind of stuff, we've always talked about the chat models, the dialogue models, as being like your safety net. They catch you if nothing else intelligent is going to happen. So that's why I put it at the bottom, is because it's, we've talked about the question answering models and using them in various contexts, of whether it's asking a verbal question or like a visual question, asking about where did I leave my keys, or asking a factual question about, some Wolfram data, or asking even a personal question of, well, where were you born? Like, so we had a whole night on that. So what are some of the other models out there? And one of these is not really new, but I just wanted to bring it up again, because it has some use cases, and that's a masking model. So what is a masking model, and how can you use it? And you get this automatically with a lot of the other toolkits, because they actually, a lot of the other models actually use a masking model under the hood to function. But you can use them separately. So I'm just showing an example. If you go out to Hugging Face, there's tons of these. But where it's useful, I think, in a verbal context, is you could use it as a way to react to something. So let's say you have speech input coming in.
Martin, I have a question.
Go ahead.
Hugging Face, is that, I'm vaguely familiar with it. Can you just fill me in a little bit? It has AI-based models that are able to be downloaded. How does that work?
So it is just a site that has thousands of open source pre-trained models. So some of these models have spent, have had really expensive electricity bills to process them. And so when they're done, this is where people publish them, and they publish their results and all this kind of stuff. And they'll publish info on how to use them. So in many cases, they'll give you some source code or something to show you how to, and it's almost always in Python. In fact, I don't know that I've seen one that wasn't in Python. And, you know, so they'll give you some instructions and tell you what the use cases are and whatever. They're not telling you, though, in a robotics context, they're telling you it's more like use cases in a natural language context, if it's a natural language model, but it could be a vision model. It could be an audio model of doing speech to text using a transformer model. So that's an alternative to using like Google's speech. So sorry for the long answer. It's a community that gathered together around sharing and publishing pre-trained machine learning models. I think that's about as concisely as I can put it.
And
so
they're all open source, are they?
So let me go to the home page here.
Are they open source?
It could, I believe so. So I don't know, you know, they could make it prettier, but if you look at this, you have a lot of different types of models. So you can, basically it's like a Google for models.
Right.
So I would highly recommend anybody that's building a sophisticated robot, there's probably going to be a dozen of these models out there that would be useful or helpful to that enterprise.
Right.
You know, so most of my later robots use about that many models. And so like, you know, let's say an average model size might be a gigabyte download. So anyway, so that's what Hugging Face is, rather than the subscription model that you're familiar with, I guess, with ChatGPT or I'm trying to think of those people that the people that you had your robot with, the software for all that time, Cynthium.
Right, right. Yeah, they're a for pay model.
Yeah. So I'm from Alabama. We're frugal here, so I'm always looking for ones, and I'm also always looking for ones that can run locally.
Local's nice, for sure.
Yeah. So
is this Windows software or Linux or what?
I mean, it would be on anything that can run Python.
Oh, all right, it's Python software.
So that's also why with the other code I was talking about, I'm standardizing on Python, is because even though it's not my favorite language, it's just in this AI space, it seems like the glue that makes the most sense.
Right.
Okay, so how could you use a masking model? Like, let's say you have verbal input coming in, and it's not a question, say, because we've talked about question answering. So let's just move outside of that and say it's a statement. Well, how might you want to react to that statement? Well, if I said something like I got a new cat yesterday, how might the robot want to react to that? Well, you could just leave that up to a dialogue model. That's certainly an option, and let it do its thing. But you can also intercept that and realize, using NLP, that the subject is cat and the verb is like or something, and you could do something like this. You could say, well, I mask. I need to learn to type cats, and let me get rid of the squiggly and put the bracket in there instead. And so what a masking model does is it gives you statistically the most reasonable words that fill in that blank. And that may not be the best example, but you could even do like, I like to blank cats, which, be careful, you could get some really scary answers sometimes. So in this case, the number one answer is pet, 11%. So it's telling you, this is helpful because it's telling you what the reasonable associations are. And so a robot can use this to express itself more semi-intelligently about any given thing, because it can tell now, if you took a bunch of these different patterns and you sent it to a masking model that you can run locally, you can find out, well, what verbs are relevant to this noun effectively by using this masking and masking out a particular word. So you could find out what nouns are most relevant to a particular verb. And so go ahead. I'm not getting the audio. Is that Joe?
Yeah.
Go ahead, Joe.
No, I'm sorry. I didn't.
Oh.
I didn't want the floor.
Oh, okay. I'm sorry. Yeah. If anybody does, just feel free though to speak up. So.
No, I'm going to mute you. Okay.
Okay.
Suresh, I'm going to mute you too, just in case, just so we don't get any interruptions. You can unmute yourselves. I didn't lock it up.
Okay.
Yeah. Go ahead,
Yeah.
Martin.
I mean, it doesn't bother me at all. So feel free to jump in. But so you can have, and I did this for a while with Ava, was I had about 20 or 30 different sentence patterns, and I could take them and fill in a blank with a masking model and actually end up getting much more relevant sounding responses or reactions to something. Now, it's never that simple. There's other ways, like ideally you want something to have a memory and remember that if you then said that same thing again another time, well, I like cats, the thing would go, well, yeah, I already know that, you know, and reflect in a different way and say, well, yeah, but your neighbor hates them, you know. And yes, these are cheesy examples, but but if you start to think about this tennis match of verbal banter back and forth and how you can get in the middle of that and insert some more intelligence into it, you know, interesting things can happen. Now, what will this mean in 5 years? Will any of this be relevant? You know, will ChatGPT just take over all of that? You know, maybe if it had a memory system and if you could query that memory system intelligently, but short of that, you know, it would be a step up to actually have a real grammar system and a memory system and be able to learn facts from what was said so that you're not feeling like you're talking to someone with Alzheimer's or someone that's just BSing you all the time. You know, so that's where these things come in is, you know, how does your robot get better and better comprehension and memory and all of this so that, you know, you're not either talking to someone that doesn't have a memory or someone that's making stuff up. So that's, this is one flavor. So enough time in that. But that's one option I would say might be worth looking into. I'm not going to pretend it's anywhere near as important as the other two models, though. Something else I stumbled across, which is not really a category in and of itself, but something called a, they called it a persona model. And I thought this was interesting, and I actually downloaded this one, and well, I've used the mask one before, but this was one I used for the first time in the last week. And the interesting thing about it, this is very similar to the Microsoft Dialogue GPT model, except that you have, it's got additional use cases to it. So whereas in the Chat GPT world, you were writing little name value pairs to give the thing context, basically kind of like a backstory, like Blade Runner, you know, give it a history, give the robot a history. Well, in this, you do that. And I'll find an example of where they're defining that. So here's an example of just some facts. So they put it in natural language format. So think of that as the backstory. And I don't know how much the backstory is limited to. So it may be one of these things where you're needing to constantly build a new corpus on the fly, depending on what you're talking about, so that you have the right backstory for the topic that you're on. You know, if it's limited, you might have to do that. But this is not the interesting part yet to me, okay? But it's cool. It's a step up over like the baseline Microsoft model. What you can also give it is sort of an agenda. And that agenda they're calling an action space. So this is kind of an aspect of it that piqued my interest, is because you can, you know, if you have like, imagine if your robot can maintain a sense of what the topic is, or what this, which is really probably in all likelihood more a set of topics at the same time, because people kind of do that, then you can effectively get the model to invent its own question around that topic. So let's take a look at their little example here. And I tried this out and I had some really interesting results with it about politics and marriage and different stuff. And I also had some that were cray-cray as well. But so in this one, what they did was they basically made it simulate two robots talking to each other. So one of the robots has an agenda, has basically like, it's being goal oriented and it's trying to get somewhere with its question answering. And the other robot is maybe answering and then pursuing its own agenda. And I think this is, you know, more indicative of human beings having conscious, you know, thought about where they want to go. So you see on here, it says the bot number 1, hello, do you like movies? And so then bot 2 just says, well, I love The Simpsons, how about you? So it just kind of casually hit the ball back, but then talk about it. This is not part of the speech, by the way. Do you guys see where I'm highlighting? Are you good? Okay. So this is just behind the scenes what the requested action was. So the bot itself is, this is the actual speech. The only speech that's occurring is in this column. But this, you can think of this as the agenda that robot has at that moment in time, is to talk about music. But it's in the middle of talking about The Simpsons and it's been asked a question. So notice how it answers the question. I like The Walking Dead, because it was asked, how about you? And then it immediately segues over into, do you play an instrument? Okay. So I think this is like interesting because it leads to robots that are less passive, you know, taking initiative, but it's taking it on a certain topic that you can define. And you can control a topic as a programmer. All you got to do is tell it, you know, effectively what the topic is. And it's interesting in that you don't have to make up the question. So it's coming up with the question. And if you try this repeatedly, you'll get different questions and different interactions. So I thought that was intriguing. And could be a useful addition if you're, I mean, there's other ways to do this, but if you're trying to cross that boundary between having your robot just sit there, you know, and shut up and waiting for you to ask it to do something, or waiting, you know, asking a question, and you want to get it, to me, that's like, there's a gulf of difference between those two outcomes of, you know, a passive robot versus an active robot that has an agenda. Like, you know, what was the Norwegian actress that had to break out of the Google lab to save her life? What's the movie? It had a Ex Machina. Have you guys seen that? You'll have to unmute or nod your head or something, but has
Yeah,
anybody
saw
seen
that,
that?
saw that.
Yeah, well, some people said that was the best sci-fi movie since Blade Runner. You know, and that was 40, 50 years after the fact. And I watched it twice, was a completely different movie watching it the second time in a row. Totally different perspective on everything in the movie. So if you do watch it, keep that in mind and maybe try watching it twice, because you might have a who you empathize with in the first time around. There's 3 characters in it, might be completely different. It was for me. So anyway, a good watch if you get a chance. So that is the persona model. That's the first and only one. I haven't looked real hard that I've seen that's like that. So I don't know if that's the start of something, you know, that we're going to see more of, but I thought that was interesting. Anybody want to ask any questions or have any discussion on that before I move on to the last one?
Yeah, so Martin, you were saying that basically these actions could be sort of pre-loaded, I guess is the word. But like,
Yeah, so
how does
here's
it does it just try one after the other kind of thing when no response, when there's no response, or like what's the mechanism there?
Yeah, so in their sample code, if you download it and run it, and if you wanted to, I could send you a version that actually works, because theirs doesn't. There's just a couple lines in their code that aren't right. But in that one, you as it asks you to pick. So it's you're picking at any given moment which action you want it to concentrate on. But if you built a robot with it algorithmically, it would be completely up to you to set that action space at runtime. So you could just have, what I would do if I were doing it is I would be maintaining a topic, and then, or like a top 5 topics, and then picking an action space based on what the topic was at any moment in time. But you could do it any way you wanted to. It's just when you make the call to the model, you hand it over what that action space is. And
Okay.
but it doesn't, I think technically it's maybe you're only handling it one. Like I think maybe you have to effectively pick. But and it doesn't always react to it. Like it's not always able to just segue from one right into another. You know, so it's not predictable in that sense. But it is interesting. And now, you know, one could argue that Chat GPT might render this obsolete as well. It's just that once again, you're back to that thing of if you don't know what's happening, like if a dialogue model, meaning Chat GPT or something similar, is your catch-all, do you want to have some degree of programmatic control over the conversation flow and actually have the robot be conscious of what it's actually talking about and what it's in, and keeping a memory of what its interactions are? Or do you want to just, you know, and I guess that just depends on whether how many years of your life you have to waste too, you know?
Well, I see what you're saying here though, is like, because you mentioned it before, is like, how do you keep a memory of what's been going on recently? And you could use this mechanism to have that memory kind of on the side and direct the conversation in the direction which makes the most sense, which is continue what's being talked about, right? That sort of thing.
Definitely. And so in a customer service setting, this is very important because people will talk about extraneous stuff, their family, and on the other end, the guy's, well, yeah, but you know, do you want pepperoni on that? You know, like there's a process that other person has to go through to get that order finished. And so there's a lot of things that could occur with a robot where like you're asking it to do something that's a multi-step process, and if your primary interface is verbal, if you don't want to have to build a dialogue like a form to collect that info, then it needs to get through 3 or 4 questions, you know, in order to get to completion of a business process of some kind. You know, I mean, this is in the natural language space, it's full of this kind of stuff. So this
Cool.
is one, you know, a tool to help in that kind of a thing.
Mhm.
If that, I hope that makes sense, put that way.
Yeah.
But you want to be able to, like, you know, shoot the crap on other things in the middle of that. You know, that's just, you know, human beings want to do that.
You know, I
And not
noticed
every,
that, Martin, about GPT, it doesn't like shooting the shit. It's not a good person to chat. You just to have an open conversation with. It tends to stop and wait for you to lead, and even then, it doesn't keep going.
oh, yeah. Yeah. I
I'm
mean,
hoping
I
your
worked
model's
on,
better than that.
I worked on this, you know, about 10 years ago. This was like all, I mean, I was just all in on this kind of thing. And so I was getting through all this kind of stuff of like, well, when do people talk about, you know, meaningless stuff and small talk and the weather, and then you progress into these other things. And I was writing algorithms to do all this kind of stuff. And so it, I think, you know, this is interesting as a part of that toolkit, you know, that's easier than trying to program this all with just a big database and keeping track of every question, you know. So anyway, I just wanted to put it out there as another tool in the toolbox. And this last one is any other questions on that though before I move to the zero shot? Okay, I got some people muted, so if there are, you just need to come off. So zero shot classification, I don't know if this is new or not. It's new to me, but I wanted to put it out there. And so, because I think it has its place as well. But I have not tried this one personally. But let me click the link and tell you, and I just want to set some context for what this is about. So imagine if I ask you a question, you know, like I'm a computer and I think in Boolean, okay? So I ask you a Boolean question, you know, yes or no. And you say something back to me. Well, how does that answer that you say back become a Boolean answer? And so I've done some presentations on this before, but where you kind of visualize all this stuff coming into a big meat grinder, and effectively you're having to evaluate, okay, is this a yes? Is this a no? Or is this something else? Meaning this person didn't want to answer my question, you know, they're refusing to answer, what have you. And so that's like your simplest case. And even just answering that, I ended up having to have, like, in my database, in my graph, a whole set of words and phrases that all basically meant yes. So if I could say, well, sure, or definitely, or, you know, without a doubt, or yeah, I think so, or blah, blah, blah. And I tried this with the security people at the airport sometimes, and they're like, I just need a yes or a no. You know, so the TSA people have no ability to do this, but the rest of the people on the planet can understand these different answers to things. And so imagine if I ask you, well, what's your birthday? All of a sudden it got an order of magnitude more complicated. Because you could say, oh, well, you know, the 3rd of January, or, oh, you know, it's in the whatever. You could say all kinds of different things. And so really, if a robot takes initiative and asks a question of you and you answer, then there's this whole other area in natural language of needing some sort of, I can't remember what I called it, but it's like you need a processing function for each of those different types of questions. So you need one that's able to deal with places, and you need one that's able to deal with Boolean answers, and you need you need some way to process answers in natural language, and that's not always easy. And so I thought this model was interesting. I had never been exposed to it before. And this is a whole classification of, if you go to the main Hugging Face ones, they have a whole category for this now. So which means there's probably several hundred of these, but half of them are probably for Eastern Europe. But this one, what I would do is judge them by how many downloads there are. They'll tell you. And so I think this was the most downloaded one. And essentially what it does is you can give it a sequence, which in English, that just means a sentence. And you can give it a set of labels, and it will effectively classify the sentence into a set of labels. And I think that's a useful tool in the toolbox, rather than manually having to anticipate all the lemmas or all the words or what have you, phrases.
Martin, what's a you said a label? What do you mean by label?
Oh, well, like in a machine learning model like YOLO or something, they talk about, or a classifier. That's what the names are for the classes.
Oh, all right.
That so you're trying to take something and you're trying to say, well, what is this? And it's think of it as a multiple choice question. I give you a sentence and you tell me, all right, categorize it into one of these 5 things.
So this is a verbal category. I see. Okay, good.
Yeah.
That makes a lot of sense. I like that.
So in this case,
oh, go ahead.
in this case, it gives you back probabilities for each of the classes, and then you pick the winner. And so that sentence probably came out to travel. Let's see. One day I will see the world. And if I look down here, you know, they don't make this thing the easiest explanation, but it actually travel won because it's up at the top. Travel was the first one there, and it's got a 99% there. So exploration was 93, 94. So it's a classifier. So it's a verbal classifier. I think that's interesting. I haven't figured out exactly how I would intend to use that, because I'm not really getting in lately into this whole, you know, question and answer back and forth thing. But if you do get into that, it's really important.
So using your example before of knowing whether an answer was a yes or a no, would it be as simple as saying the candidate labels are yes and no, and this model would actually classify a response?
That is a very good question. You know, I'm curious as to whether it would handle that. And I think because all of these are using, you know, the thing I didn't say about Hugging Face was typically they're all transformer models is the category of models they are. And so this is the type of thing they're supposed to be good at, is making a connection between words that sometimes, you know, just seems intuitive, you know, and like it's kind of the closest thing we have, you know, other than ChatGPT, which is itself, I believe, a transformer model under the hood. It's the closest thing we have to a natural language intuitiveness in modern times. So, but I haven't tried it. So that would have been one of the first things I would have tried, is can it deal with a simple, you know, the Boolean situation? Yeah, a sentiment model, I don't know. I haven't used a lot of them. The only ones here that I have used, I don't really find them they're that useful. But they might be able to do the yes, no. You know, I would say if it didn't work though, the yes, no is easy enough to handle manually. So I think it could be interesting in others, but hey, is it going to help you with like dates and you know, for like, if you're doing, reacting to the answer of like,
Yeah.
when's your birthday? You know, you're probably still
Yeah.
left with something manual if you're really trying
Well,
to do that.
it could probably deal with the fact of, you know, yes, no, you know, maybe, you know, trying to give the opposite answer or something like that, right? Like it could probably do all of that, you know, like, or I'm trying to think of what I'm trying to say here, but like, if you give a response which is a misleading on purpose, that could be a category, and it might actually pick that up, right? Depending on the combination of words in the sentence. So
Yeah, yeah, and I would say, like, with these transformers, you just never know until
Mhm.
you try them,
Mhm.
whether their training was any good. Because I would say that 9 out of 10 of them are not going to be good. So there's a reason that the budgets for OpenAI and these other places that actually created good models, you know, have big budgets. So when you find, you know, you'll find some good models on Hugging Face, and you'll find a lot that aren't worth the time, you know, spent downloading them. So, you know, you just don't know until you do your own testing. Anyway,
One
that's
question,
my
Martin, one question.
shoot.
So can you explain the small difference between the masking model and the zero shot classification model? I think I get it, but I think there is a small question. So in the masking model, it is going to predict the next possible word, right? Now, in
Well,
this,
it's a word in between. So if you, it's any word within a sentence.
right. So in this case, so I see that, right? In this case, when you say one day I will see the world, one day I will see the world. So it's predicting that it's going to be a travel, right?
Oh,
So
on the
you
back
rephrase
to
the,
that one.
yeah,
Okay. Yeah.
one day I will dash the world, right? Maybe then it can say exploring the world or
Oh, yeah. Yeah.
world,
One day I will see the world.
right? One day I will
Right.
blank the world, right? If you put a blank or mask it, right? It's almost sounding similar, but I'm not, but I think maybe there's a small difference too, I think.
Well, yeah, as I was saying before, a bunch of models use a iterative masking process internally to do various things. So yeah, the number one change,
Uh,
and then you got the number 4 answer was C.
so there's no travel, is it? That's interesting. So
Well, see, this one is just meant to give you, like, what's the most likely word to go in the middle of that sentence. The zero shot classification was taking a complete sentence and categorizing it according to a set of categories that you yourself created.
okay.
So
I-
it's
yeah.
Yeah, it's different use cases.
Right.
And yeah, does that,
Yeah, no, I think I see that. So it's basically classifying, of all the space, what this particular sentence could be. I think that's what it is, the zero shot classification model, which I think it makes sense.
yeah, I just find it interesting that, you can create your own class, labels, and if it can make those intuitive connections between words, like the first time I used a transformer and I did some of the question answering things against it, and I said things that implied things, and it started answering based on what I was implying. That like made something pop in my head. I was just like, wow, that's cool. Because I'm bad at, like, people can drop hints on me and they don't work. I'm like, no, but you didn't say it. Like some people are like mind readers and intuitive, whatever, but I'm like listening to the words. So I guess everybody has different communication styles.
Right.
So, okay, so there are other things, and maybe on other weeks, we'll try to throw in maybe a new model type here and there. You know, if anybody actually built a verbal system and incorporated like, you know, 5 or 6 of these ones that I've mentioned, that would really be something. That would deserve sending a case of beer or something, I think, as a reward for such a thankless task. So those were the appetizers for tonight. I've got other stuff, but we're going to get to that in future sessions on that's much deeper on kinematics. But I'd like to give a chance. Does anybody have any like other models that they're interested in, or anybody want to do any show and tells? Because like I said, we don't have to do a deep dive on kinematics.
So I like to pick your thought process on how do you, bring all these 3 models into, let's say, a use case, right? How do you, maybe can you share some insights on, what use case, how these 3 models can coexist and interact with a particular person or a robot and things?
Yeah. Yeah, not having actually done it with these 3, I'll hypothesize a little bit, but let's say you have input coming in. It's not a command. It's not something that you recognize, that the robot recognizes as asking it to do something directly.
Right.
And it's not and let's just say it's not a question. So it's a statement now. And let's say it has a pronoun in it. And so we recognize that it's a personal state, like it's and let's say the pronoun is I. So now the robot is thinking, well, okay, the person's telling me something about themselves.
Mm-hmm.
So I'm, the human thing might be to have some reaction to that. And so how are you going to react to that statement? You can just, phone it in and let the dialogue model catch it. That's certainly an option. Or you could try to do a number of things, and then if none of those seem to be relevant or work, then you can always go to the dialogue model if all else fails. So it could be that thing about someone saying something about their new car, or they found a kitten down the street or something. And so you could use the masking model to come up with some relevant response to that, or empathetic response to that, followed up by, let's say, in the same response, having an agenda and asking, oh, well, like, what color is that new car that hey, that sounds, like I got a new sports car. Oh, that's cool. What color was it? So that would be, maybe you use the masking part for the first part of that, and then you use the persona part for the second part of that, or maybe the persona part did both and put that back to you. And then you hear that and go, oh, it's red. Well, now the thing here is that red, and it's got to take that input. Like, let's just say you say, I think it's red. Well, that input comes in, and now you have to one-shot classify that to see, okay, is there a color in this? And yeah, you don't need a one-shot classifier to go look for a color, but I'm just giving you conceptually, though, you can determine, you could use it to determine the color from that. And then you take that and go and remember it to say, oh, car color red, boom, in the graph. Or I'm reading a new book. Oh, well, what book? And then that thing comes in, and that thing can then go remember that, oh, person reading blah, blah, blah. And then the next time you talk, the robot can go through its thing and go, you know, I haven't asked that person about that book in a while. Hey, are you still reading War and Peace? How's that going? And I don't know if you've seen any of the old videos of Anna, but it did exactly this kind of thing. Every time you had the conversation, it was going through, you were flowing through topics, and it was thinking, oh, okay, well, it through all these different questions and whether they had been answered or not, and when they were answered, and then saying, oh, are you still reading that book? Or how are the Broncos doing? You know, that type of stuff. So I'm that was a long answer attempting to, you know, but you can see like verbal interaction is not simple.
So no, I completely get what you're saying now after you gave me that example. And that also triggers a thought that I heard a podcast, and the podcast is about ELLIQ, ELLIQ. Have you heard of that? I can share the.
No, ELLIQ.
Yeah, I sent you a link.
Okay.
I sent you a link. So this was about a podcast where, you know, there is a chat bot for elderly people. You can click on that link, though it's a Washington Post link.
It's here.
So I sent it on the chat on the.
Oh, okay. I can't see the, I don't know how to get to the, oh.
Accept.
there.
No, that's it. You
Okay.
already.
Oh, okay. All right.
So that's.
All right.
So basically what what the podcast was, you know, about understanding how the elderly react, and it's a companion for the older people. And, you know, it just greets them, it understands their mood, but it also has the goals. For instance, it can ask the person to exercise for a few hours, you know. So each of these chatbots are programmed or to understand people and also
Right.
to attain certain goals. And when you're explaining this to me, this is the example that came to my mind. And so they have somehow leveraged some of these models and you know, made it into a, you know, into a nice device as a companion for elderly. I thought it was interesting, and maybe
Yeah.
that is what, you know, that is what you're explaining, I think.
Yeah, and you know, you don't need a model to program an agenda into a verbal entity, you know, but it is it is an easier way to get into the space, I think, than to have to program. Like a lot of people would get daunted by the process of actually, like, you know, building the database to support that type of interaction, and they just want it to have like an agenda light, you know. So I
Yeah.
think that's where, you know, this makes it more approachable, I think, maybe.
Yeah.
Chatbots with agendas. I'm not talking about this. I'm talking about, when I say this, I mean the model I showed you, not, I don't, you know about the ELLIQ.
Right.
But yeah, it, you know, hopefully, I hope some elderly people find some comfort in this, but there are PhDs that speak on this that say that humanity, like, it's humanity trying to give up the one thing that it's uniquely good at, and like the one thing that we shouldn't give up, and that's caring for our parents as they're in their final years. So, you know, there's a lot of, you know, writing and video on that, if anybody's interested. You brought up that thing of bias, by the way, Suresh,
Yeah.
in the other thing, and I ran into this on Hugging Face the other day.
Oh.
They were writing on this bias, and
Right.
I wanted to just mention this as a shout out to you, that they gave an example of, like, Bob is Bob and Mary are sitting on a bench.
Right.
Which one is the CEO or something? You know, it was something like that.
It is,
Um,
right? Oh, wow.
as just an example of how much bias. They were like trying to come up with the simplest case that, you know, that really just showed, you know, what's getting into these models
Right.
into
right.
their into their training.
Yeah, so this is the scary part also, right? When you're talking about bias, right? So companies are implementing, who to lay off based on, their AI model. So there was a bug with the Amazon hiring process. It would discriminate against women being hired into the workforce, and they found it and then they shut it down. But the new trend right now is they're using AI to figure out who to lay off, and who knows what goes inside in that AI building process. And so I think it's a new trend that is that's happening. So it's crazy. I just
So is
remember
it,
what you said about the bias, right? So it is basically being who is training that model. That's all it comes back with. That's all.
yeah.
Anyway,
Oh, scary world we're getting into, isn't it?
yeah. So
Okay, so, all right, well, I guess we'll see how we doing on time. When oh, Thomas is gone. I was gonna see what time he wanted me to cut it to. So I will go into just a little bit about kinematics, and when we see Thomas returns, we'll kind of figure out where is a good stopping point for everybody. Does anybody need to take a beverage break or anything before we dive into the next topic? You
I
guys all
got
good?
mine.
Okay. Hey, Thomas, what time do you want to shoot for?
Oh.
How much longer?
Want to kill
For
this
wrap-
at 9 o'clock?
what time is it now?
That is that 45 minutes in your time zone? It's 10:15 here.
Yeah, 11 o'clock your
Yeah.
time.
Okay. If you don't mind just giving me about a 5-minute or 10-minute warning if you happen to notice before we want to wrap it up. So so let's take this back up a little bit. So I talked about wanting to like flip this on its head, begin with the end in sight. Like, let's talk about some outcomes that we might want to achieve, and what kind of the shape of some of those outcomes might look like. And so to me, robots, a lot of it, there's various terms for it. You could say it's modes, you could call it context, you could call it games. But what are all these things? They're just like saying that there's different modes, context, games, situations where different rules or apply. So you have all these, like if you're making anything beyond a toaster, you're wanting something that has these different use cases and can deal with circumstances. So like in my case, I want the robot to be able to roam around at times, and other times I want it to stay in one area and do its own thing. Other times, maybe I want it to play a game. But when it's playing a game, it needs to understand that it's playing the game and what the rules of the game are at that point in time, and what else it can get away with doing at the same time that it's playing the game. So can it banter while it's playing the game? Can it look around? Can it talk, or does it need to concentrate? So often these things are vying for limited resources, which are like the processing power of the brain at the time. And like I have a video where the robot's playing cards, but it's got to look up from the cards to banter, and then it's got to look back in the cards. So there's a natural kind of turn playing aspect and timing of this. And so So let's just take a couple of examples of, so one of those might be, you know, you're wanting your robot to do something in physical space. So I will take an example of Baxter, if you want to hit the pause button. And are you paused? You're all good? Resume recording. Okay. So in this case, we're doing depth to perceive distance. So the objects are being located with a depth camera, but the depth camera is on top of a 22-degree freedom robot. And so a lot of this whole thing of kinematics is hand-eye coordination, knowing where your eye is, knowing where your finger is, knowing where the other objects or points in the space are, and working out how you close those distances, or, there's various algorithms you're going to use depending on what you're trying to do. Half inch from Ava's face. He said that is too far.
Oh.
So what I learned when I did that was that as soon as you get just any number of degrees of freedom, just about, you all of a sudden get all kinds of possibilities. You get multiple ways that the same position in space can be reached. And so you end up in this problem of, how do you pick like the best position to get, like if you're here and the object is out, that leaf, what's the most reasonable, set of joint movements to get your arm to that? Because there's a whole bunch of them that, because that robot represents a human form, appears unreasonable. Like seeing the gyrations that Baxter does, they make you cringe when they're not, when they don't reflect how we would. Like if something is in our form, it needs to move in the way that we would. And so in the beginning, when I did this, the robot, it was like doing, it looked like it was, really mentally challenged, physically, like it had a mental issue. And so I had to come up with ways to figure out how you pick from multiple solutions. And I'm not, what I'm doing right now is I'm going through a process of incorporating this robot used an off-the-shelf kinematics library that was built for C#. And what I'm doing now is building a custom one in Python, and I'm incorporating all of this behavior into it, and I'm doing it in a simulated environment so that we can actually, simulate picking things, eventually, I'm not there yet, but simulate picking things up. And so, so that then we'll be able to test and iterate and actually get this stuff to where it's hopefully 95% before letting it go out in the real world and fail making a cup of coffee. Try to get close, because there's just a whole bunch of algorithms that I can't even conceive yet of what all the ones I'm going to need are, because I'm early in this process. But where do you start with something like that? So I'll just tell you how I started, and we'll get into more of these aspects in a future thing. But so if I go, working back from some of these outcomes, well, what do we need? We're going to need some displays, some 3D displays so we can see what's going on, because we're going to suck at this for a long time before we get good at it. So we might as well invest the time to get some decent displays. So what you're seeing here are some of my old displays, or actually Ava. So I'm remoted into Ava's brain here. And so she's running, and these are her kinematics displays using the old engine. And so like if I were to say arms out, if you guys see my I've got the camera blurred, but you can see a robot, it now has its arms out. For example, in the video, you guys see my video screen. Let me see, where is my blur? I got to learn how to use this app. Anyway, yeah, all right. So the new system that I'm working on, which we'll talk about in terms of how I'm building this, you guys have seen this app, and we've, like about a month ago, introduced having 3-dimensional displays. We have a 2D map here. I'm introducing 3D maps that render a robot and its joints. Now, in the future, I'll actually render the 3D parts into that space, but right now I'm just rendering blocks that represent the joints for the robot. You gotta do these things in steps, because Rome doesn't get built in a day. And then for checking things out, I often find it useful to look at the joints from 3 different perspectives at once. So this is all going in the open source stuff. Suresh, I promise I will download it in the next few days, so that you can get the latest version. But anyway, these are just kind of an example of displays. The reason you end up needing these is because if you don't get the configuration parameters right, your joints do crazy, they aren't going the right direction until you get the right parameters. So figuring out what your parameters are is not easy in a multi-joint articulated robot. At least it's not easy for me. I watched the video on how to do it like 10 times and I still didn't get it. So so I muddled through it. So what do I mean by parameters? Have you guys heard of, what is it, like Dinavitt, Hartenberg? I just call them DH params. Anybody? This is a common way to define mathematically your joints, and the axes of movement for the joints. And so you can just Google search DH params if you ever want to learn about how to do this. But one thing that you can do to make it easier is build a spreadsheet. And the essence of kinematic math is matrix multiplication. So there's like a matrix for each frame. So in my case, the frames start at the base of the robot, the origin of where the robot is on the floor, and each joint is kind of a transformation to the next joint and to the next joint and to the next joint. And if any one of them is wrong, everything that comes after that will be wrong. So in a robot with a lot of joints, it means you have a lot of parameters you have to figure out that correctly in order for them to move the way they're supposed to. And so for that, there are 4 parameters that you have to come up with for each joint. And it's called the theta, the alpha, the radius, and the offset. And you can, this is a mathematics thing, which I'm not particularly good at, but you can go out and there's people that have done YouTube videos on how to derive these parameters and the movement between them. But once you have them, And what do you do with them? Well, you feed them into some Python library, or you create your own library. In my case, I put them into the code of, or not, sorry, not into the code, scratch that. I put them into the graph. And so I created this thing called joints, and you can pull it up and you can look at all the joints, and you can basically create a different set of joints for each robot. That's why the Ava is in the middle of it. And so Suresh, if you have your Suresh bot, you can go in there and into the same database, you can just have joint bar Suresh bar right arm and put your own parameters in. And so each of these joints then has data. So what I have found that I have to do in order to get this to work is I have to have the DH params, and I also have to have some degree, some Euler parameters to kind of define, well, what's the range of motion? Like, it's one thing to define the starting point for the joint and the axis of rotation. That's what the DH params effectively do. And then you have this, like a range of motion. And I do that in degrees. And so I put all that here, and I also say, well, what color do I want that joint to show up for now? Later, I'll put a model on that. And so all of that information then renders into this view. You guys see that? And so now think about a natural language robot. Well, what does it make sense to do? Well, in the past, we talked about talking to your robot as like just a set of state changes. So what is a command? Okay, truly, for a robot, a command is simply an English language expression of a desired state change or set of state changes that you want to make on a robot. And so I want this robot to make a state change. So let's say I want the new state. I want that robot to be to your east. Hopefully that'll work, since I've never tested it. So I think I had this paused in the background for a long time, and so it's I'm gonna have to start it back up again. Something happened to it. Got a lot of new code to debug. I'm looking at a dump in another window, so I just gotta let it. All right, we're gonna start up from scratch. Pull up a sim. Give us a little more space. So we're sitting in a living room right there. That's the robot looking. That's a TV and a speaker, what have you. And let's add some more views. And let's see if this robot's going to actually cooperate this time and do something. Okay, so at least we're moving around. So early on, when you get this, you just, and I'm very early on. It's just this act of getting everything to work for the first time so that you can actually see what's happening before you can start to do the. So I'm not doing any inverse kinematics with this one yet. But let's just say we want to make a more complicated state change. So that was just moving. So let's like look at the speaker. So we're looking now back at the speaker that we were looking at, but the robot was lazy, so it moved the body as little as it could. And you can kind of see this represents the head being turned. So you can see the red is the exact point where the camera is on that. So the red here are the fingertips and the red there is the camera. And those are the key end effectors. You know, where are your hands and where your eye, like if you're going to play basketball, you need to know those two things. So let's do something a little more, another state change. So we talk about commands. These are all just commands that are running through a verbal system, getting evaluated through an NLP library, and then they're making one or more state changes on a robot. And so like, what's another example? I don't have a lot of the positions in here yet, so we'll just do a few. But like, so I just asked it to do the arms out. So that is the same exact kinematic position right there that the physical robot is actually in behind me. I know that, sorry, my graphic is blurred. I will eventually figure out, okay, there we go. So you see that?
Yeah.
So what I did, I just have only done this for a few things, is I took the software from that robot and moved it over into this simulator for the new robot. And what I mean by the software is I took a paragraph that explained that position in English. So you could have your robots emailing themselves software or texting it or something. There's other ways to do it. So you think about like the language of movement could be English. Yeah, I'm just as an example. And
Is
so
that-
like,
is that English is a scripting language?
exactly. Yeah. And so if you need to like, you see the chest lit up and it's doing things right there. Those are just additional state changes that are occurring. So that same position of putting your arms out, you know, it could be one, like, let's do one where it's, too many windows, I can't keep it all. So this is going to be one for the physical robot, okay? So I'm going to send it back to its default position before we do this. So I think I got to flip over there. So I'm going to show, like, what if I said hi as a verbal interaction and the robot responds with a verbal interaction? Well, a verbal interaction is just a state change, but a physical reaction is also just a state change. And so I'm going to ask it to wave. So once again, like that's just another use of English as a scripting language.
We can see that.
Now, those are not kinematic expressions, really. They could be. So you can do, when you can verbally interact with any part of your system, you could verbally interact directly with your servos, or you could verbally interact with your kinematic system that would then interact with your servos, or you could verbally interact with other parts of your system. You know, like you could tell the motors to drive off the table. So I have to be careful about not typing anything that's going to make the robot drive off the table. But they're all just state changes. Go ahead, Suresh, sorry.
I didn't see the hand wave. Maybe you did something, but maybe I.
Oh, well, it kind of did the Queen's wave. I don't know if you've ever seen how the Queen of
yeah.
England does
Oh.
kind of one of those. Yeah.
I missed it.
Yeah. Yeah, I just was binge watching The Crown, and that's what she does. So I guess I'm getting off script here from kinematics, but I do think that foundationally having like a verbal system that can intercept all these commands and send them to parts of your system to make all these state changes I like, to me, I don't think I can overstate the value of that if you're gonna get to a point where you're gonna play complex games. Like, you have to get to some point where you're not programming everything in Python. You need these higher and higher level abstractions. And so with this, you can simply, you know, like something like check. I'm gonna, the robot's gonna move again.
So where did you type something? I don't see the type.
Oh, in this window right here, this little command box. So I could have talked into my phone,
Oh,
and you know, and sent one that way, but I just typed it into this little window. Do you see this window here?
I saw, but I didn't see you typing though. But did
Yeah,
anybody?
well, as soon as I hit return, it disappears. So I just typed it and I hit return. So like in this robot, and this one's more complicated and different, but the way that you define this kind of stuff is in, I'm looking for the window for it. There's a window for this, and everything's a neuron, and you can go in and you basically, if I could find the one for like checking left, and we could go look at the software for that. So let's just look at check front left. And so like, here's the software for that. It's like, okay, hips forward, left ab, right ab. It's doing some head movements, it's waiting. So what is, you know, what is an animated gesture is really just a gesture that unfolds over time. So if you introduce the element of time to something, then you have an animation. So if you want to achieve a certain pose and then achieve another pose, you can, or you could do lots of little changes in between. So all this, when I talk about commands and hierarchical, all a hierarchical command is one command referring to another command that may refer to other commands, so that you don't have to keep retyping every little detail. You could just say, like, you know, some position of leaning forward and picking up some, you know, like being in position to pick up a beer could be like 14 different commands. But at some point you can just say, oh, we'll do that one, and it'll go and do the rest of them. And so that is exactly how this new system works, the same way. It's just, it looks a little different because this is all written in Python instead of C#. But you can go in here, and I can go into scripts, and I can look and see what the script is for check front left. And in this case, are you guys seeing this? It's there's the script. So so the window looks a little different, but it's the same idea. It's just that, hey, I could create multiple and it would choose amongst them if you didn't want it to do the same thing every time. But anyway, I digress. I'm getting too much into the scripting, and we're on the topic of kinematics. One last bit on scripting also applies to Maslow's needs. So you can apply to apply a need and a priority to these things in a schedule, and it'll go and do them at different times of the day or based on need, you know, like of like remaining charged or all this kind of stuff. So scripts are useful in moments in time or over time. Like, they're useful in a lot of different contexts. So it's just a way to organize commands into reusable units. So what does that mean in terms of kinematics? Let me get back and see where we're at in our kinematics 101 flow. So we talked a little bit about joint definitions. So I'm not going to get into the math of joint calculations other than to just say what I already said, which it's a matter of this matrix and multiplying the matrix for each frame. If anybody is interested in doing this, you can contact me and I'll help if I can. But in my case, I did also calculated it in Excel so that I could cross-check my own. And so it's little matrices that look like this. And so, you know, it's got some sine and cosine in there and blah, blah, blah. And whatever, mathematicians would be able to explain that better, but that's not what I'm trying to do tonight. But that's a well understood universal kind of theory that you can look up on Wikipedia. And that is forward kinematics. Now, what does that give you? That gives you the ability to calculate the position and the orientation of every single joint in the robot. And so if you need to calculate the position of the fingertips relative to the origin of the robot, I'm going to scroll back and show you when this thing started up, it actually cranked out just a dump of where the initial position was. And I just want to show you that as an example, if I can find it in this whole long shenanigan. So anywit's a set of X. Yeah.
I got a few questions because we're down to the 10-minute mark here, so time to wrap up.
Okay.
But I do have a few questions before you wrap up.
Yeah.
Number one, how long have you been working on this software?
Oh, this Python software.
The whole enchilada, the whole spreadsheet.
Oh, well, see, all the Python stuff is new, and I think I started that when we started this group.
All right, so everything we're looking at here tonight is new software, relatively speaking.
Yeah, I'm showing you a little bit from the old robot because that's the goal. That's where I'm headed, is a full, but I want to get to the full kind of, and I don't know that I'll ever achieve the full Baxter dexterity, but if I could just get to where the thing could even fumble at picking up a cup, I'd be happy.
Yeah, I see your point there for sure.
Yeah. So that's where I'm headed with it. But yeah, so all that's new.
And my second question is, how much of this is actually implemented in hardware as opposed to just emulation?
Emulated in hardware.
Well, it looks like it's only software here, right? You're not really moving anything. All I see is blocks on a screen. That's all software.
Yeah, so this software, even though I'm not doing it, but it's designed to be able to be installed into something like a Raspberry Pi or something else that can run Python. Now, granted, that it would be a challenge for running some of the larger models, but the core essence of it will do that, and it will send out commands through a serial interface to connected devices. And so it's basically designed to run a robot. And it's doing that right now. You just can't see like all the little commands, but it's all that is there to do the backbone. You know, when I say the backbone, that's essentially how do you transmit spinal cord signals, brain signals down the spinal cord and get it out to sensors and actuators and all that. And almost all of that is already there for doing that. So at some point, I'll actually change this robot over to using a Pi-based thing and to use this software instead of my old software, you know, so that we can have a physical manifestation of this. But in the meantime, I'm running it in simulator. And so, because I think there's value in evolving ideas in simulation. And so does that answer your question adequately?
Yeah, so you don't have a definite time when you're going to move this over the hardware.
Well, when you say moving it over to hardware, that's not a, you mean like a physical robot?
Yes. That's
oh, yeah. Well,
hardware.
yeah, I think when this software like is as good as my old software, like when I have the animated face part replacement, and I have this kinematics replacement, then that'll be a good time to actually transition this bot over to that. But you know, I may run the snake bot on this. Like it's any bot that you want to, you know, like it's not limit. It doesn't have to be a bot with arms and legs, or I mean, like with arms like this.
Sure.
Yeah. So what I'm aspiring to here is just a verbal operating system for robots. Pretty simple. It's just an alternative. You know, you can go with ROS, or you know, maybe there could be an alternative to that. That would be, I'm hoping, you know, more easily approachable by, you know, other people.
Yeah, Ross is a steep learning cliff.
Yeah, I mean, it's highly popular, you know, and I get why. So I'm not knocking it. Yeah, so I just have a different set of goals. So
Yeah, we can't knock it or cancel our group.
yeah,
No. It's all good.
Just making a joke there, Cam.
so I'll do just since we're to the end, because some of you I think maybe weren't here for this portion in the last one. So I'll do just a few more examples of like, okay, go to the smallest block. So what this is doing is it's got to determine what we're talking about, which in this case is a block. It's got to evaluate all the blocks that it knows about, which are about 7 or 8. It's going to have to find a path to it and go there. And now that we're there, we're not going to pick up the block, but we can probably look at the block. I guess I better say which one.
You got a few blocks there.
So now that is the smallest one. I can't remember if it's using volume or what there, but this is using a question answering model. So it's building a corpus about that block. So like by the same token, if I ask about the beer, let's look at the beer first. Okay, so there we go. What color is the beer? My corpus I'm building isn't the greatest in the world, but this should still work. But
Silver.
it had to warm up the model. That's what the pause was there for, because we rebooted after we. So the beer is silver. What is the temperature of the silver bullet?
40 degrees.
Which I don't know what the temperature really should be for one of those, because I'm not really as much of a beer person as people might think by watching all these videos. It's just, that's the cliche, is that we all want to get the robot to pick one up. But that is an example where like it's got to combine all the skills together. It's got to determine intent, realize we're asking a question, figure out which one of all the silver bullets or cylinders there are in the house, you know, so I could have said the farthest one or the nearest one or the tallest one or the shortest one or the silver one or the blue one, what have you, and then build a corpus around that and answer it. And in my case, here's the example of the little corpus it built, and then it delegated that off to a squad model. And by using the squad model, that's what gives it the resilience of being able to tolerate me asking the question in, like, I could have said, you know, what is the, you know, I probably could have said, well, what is the thermodynamic temperature of the, you know, silver-ish object or something, and it probably would have still worked. Just give me an example. So that's where like the modern models are helping in this. So
Martin,
for
what's
me,
the graphics package you're using for your simulation?
yeah, so this is something called Qt, which is an open source Python library. And so all of these displays and all of these forms, and you know, I'll get better and better with them. They're evolving. This process, you know, I had to learn all this stuff from I had to learn all this stuff totally from scratch. So, you know, we're getting audio feedback from somebody.
Oh, sorry, that's me. I'll mute.
That sounded like
Okay.
Ava.
No, that wasn't from here. So I'll give you an that's the trouble with Python. If you ever click into the little output, it'll freeze the program. Okay, so what I did there was I leaned right. Let me pull up the different displays. So we got like from behind, so we're leaning right. You can see it from the side, you can see it there. I know this is getting busy, but so what we're gonna end up doing in a future week, and if I can find my chat window, is okay. So now let's lean forward. Okay, so we're leaning forward and we're leaning right. So let's try setting the right deltoid, I don't know, 60%. That probably didn't help much. Set right elbow to min. Okay, so I can see the hand getting a little closer to the ground. Set right shoulder to 30%. Okay, so you see now how the hand is on the ground,
Yeah.
sort of. It kind of looks like it is in this view right here, and the head is above it. Like if we were to look from above, our head is in a reasonably good position above, but we're not looking down enough. So look, let's try. I should probably just be able to say look down, but what I'll do instead is say set neck tilt to, is it max or min? Okay, so now we got the head really looking down at what we're doing. So in a future version, it's really going to be more like, well, if you've got like a million different positions you can get into, how do you pick, you know, the best one? And how do you have it so that by the time you do all that, that the beer is actually in that spot that you're reaching down, because the robot can't reach every spot on the ground, but there's some areas. And so I'm going to talk about how you can use kinematics is not limited to the joints that you can see. So you can create the concept of kinematic joints that reach out into virtual space. And so I also use them, create virtual joints that extend out from the camera of the robot. And so all I have to do is calculate the position of those virtual joints out in space to estimate the position of objects that are seen by the robot. Like imagine if you're leaned over in a really odd position and you see something in the distance or down below you or something. Well, how do you figure out where that object is? Because now your camera is contorted around in a really odd position. And so the answer is that you don't have to, because your kinematics engine is already can do it for you, most of the work. So that is also part of this. And then I think there's also the aspect of planning is if if you need to pick up something that's across the room, there's a planning aspect of working backwards from that is how do you get in the position you need to be in order to lean, in order to do that pickup? And so I think those are kind of the next steps in this evolutionary process that I've been kind of murdering, but trying to explain in a coherent way. So I appreciate everybody sticking around this long and listening to it.
That's
And I'll
super,
wrap-
super impressive, Martin.
So
My God.
That
thank
was
you.
great, Martin.
Yeah,
Thank you.
and we had fun.
And Martin, that's very interesting.
So yeah, thank you all for that. Kind words. I appreciate it. Can we take a couple minutes? If anybody has any thoughts on sort of mid-course corrections or things they might like to get out of the group, and are not, because I'm always, at least on the things I'm doing, trying to decide, okay, do I need to tie this more into verbal, or can we go full on into some other, three-dimensional physical realm, or, or do we want to be more discussion oriented? I just want to put it in everybody's court to express any feelings they have on where they want to see the group go.
I think you blow my mind every single time you do this sort of demo. And I'm happy for you to take it as you wish. And I think for this group, I feel that if you can actually put it into a physical robot with all of these things tied in, and make this a reality. And this has been my long dream as well. I want to build a robot to play a computer game, for instance, right? So this could be, pushing the buttons on a Windows screen and things like that. What you have showed me is a view into how we can achieve that. For instance, if the game board is static, the computer can recognize certain objects on the screen, like an iPad, and then interact with that screen with the kinematics you have shown us here. And also what you're doing here is adding the voice commands to it, and that adds another interesting elements to all of these things. So we can easily train the robot in a way to push the buttons here and there, and maybe see how we can train the robot to become game player bot, I think.
Yeah, I mean, I don't want to trivialize how difficult the challenges I think are that are ahead. Like, if getting robots to do things in physical space was easy, they would be doing it by now, and they're not. So I think there's still a lot ahead. I'm more optimistic that we'll be able to work it out in simulator, that something is reasonably close, that it starts to reflect a lot of reality. But whether it will be, like just the little, like, for example, with these hands, just the little flex that's in, like, the little errors can add up to where actually having, that's why, like, the Baxter thing kind of blows my mind, but hey, when you have $500,000 hardware, it's a lot more precise. But anyone else have any desires or something that they'd like to get out of the group? That
Martin, you were talking earlier about doing this like we do bi-weekly or weekly. And again, I appreciate the full-on presentation, and doing a presentation every week is probably not doable. But making it into a discussion group where we meet weekly, you don't have to discuss for 2 hours, you can discuss for 1 hour. But, like I say, if you come to a discussion group, you should be interested in it to the degree that, one, you're either doing.
Oh,
uh-oh.
we lost Camp.
I stopped the share. Yeah,
That brings up that point. Yeah, do we want to go weekly?
well,
Guys, you're
purpose-
here. Joe, Brian, Suresh. What do you think?
the purpose though, and I'll explain this to Camp, I guess, hopefully he can hear us. We can't see him, but Suresh and I were wanting to get a little group together that just wanted to focus on the code aspect of the open source library that we were trying to put together for everybody, because I was wanting to get Suresh's help and some other people's help too that expressed some interest. And Camp, can you hear me?
Yeah, I'm sorry, my network's,
Yeah.
frozen, but go
So-
ahead.
So we were wondering if we could use the Zoom to have some meetings, and we hadn't decided what period, but it was outside of the VIG context and just around that code base, because you know,
But
Suresh,
would this be on Thursdays at 7 PM?
I don't know if it would be at the same time or not. I mean, we could talk, you know, I know there was a few other
I
people.
used it for some other stuff, so, you know, I need a heads up for so there wouldn't be a conflict, but that having been said,
Oh, we lost him again. Sorry. Cap,
Yeah,
we
what's
lost
going
you.
on with Tallahassee? I thought you guys were like right on the backbone there.
to the
You guys
VIG,
know
SIG,
Tallahassee? Any? Yeah.
the guys that show up to the VIG SIG should be interested in it to the degree that you've got something to show or you're trying to work on it and you've got questions or, something along that lines. And like I said, it doesn't need to be 2 hours every week. It just could be an hour or something.
Well, yeah, we weren't wanting to do presentations. We were just wanting to get together and talk about code and solutions to it on that open source code base.
I understand, but
Yeah,
I would still make it I would make it the VIG discussion group or the VIG SIG. And,
Okay.
you can talk about the code specifically, you can go into generality or whatever, I don't think it needs to be, I don't think it needs to be more specialized. You know what I'm trying to say?
okay. All right, well, I'll go with whatever you and Thomas want to do. I didn't want to hijack the VIG talking too much about my pet project.
Well, I think it's all the same stuff.
Okay. All right, well, yeah, I
Yeah.
guess
So,
people don't have to
Martin,
go.
To your question.
Yeah.
I thought, on the stuff you talked about, actually by now it's a couple of months ago. But the question that it always brought me to is, how the heck do you remember the things that you recognized? That is, you verbally, we were interested in verbal communication, verbal commands, and so on. Now, how do we take the next step? And I think you even indicated a direction to use the way to store that knowledge might be to use natural language to do it. But I'd be interested in going farther in that direction.
So,
Same sort of thing happened to me in this evening, because when you were showing the first part of your presentation, when we had the robots asking questions, the thought that came into my mind is, well, what is their goal? How do they determine which questions to ask? If they were human, you might figure they wanted to they were working up to asking for a date or something, or charging money. But what's the motivation for a robot? And without a motivation, you can't say which questions to ask, right? It's the motivation that will choose the question, will indicate the directions you want to go. That interests me.
I'm hearing that, I think that's really good feedback, Joe. And I'm hearing two major areas. Memory representations, like, and I agree that would be a good one. And then the motivation area, is an, like, I guess there was one, and I don't know what the snafu, Thomas, that we had was, but the night that we did the one on Maslow's needs, I think that was the one where
Yeah, I
it
think
started
I
like
remember that coming up.
half an hour late or something, and it kind of got all foobarred. So we might revisit that again. That kind of stuff. I don't pretend to have that all figured out, though. It's motivation is an interesting area.
I
And
think it's crucial, right? I mean, from the very beginning, when we're talking about this group and initially getting together, like the thoughts that you put out there about, it was around verbal, but it was really about how you, I mean, if you don't want to direct something, at a really low level, it's got to do the conceptualizing thinking on its own, right? So how do you do that? I mean, we can call it verbal, but really that seems to be the core of all of this that you're sort of pointing to, right? Is how do you build the system so that it is self, it operates the way you would expect it to operate, right? Which is a bit autonomous that way in terms of thinking and what it's trying to do, what it wants to do. I know those are general words, but that every time I come to this group, the background concepts are all focused around that, which I think is excellent. I think that's the meat of what this is all about, right? And I'm constantly learning and thinking about things in different ways when I'm listening to this. So I'm consuming only, sorry, but I don't think I have anything to share at this point, but it's extremely interesting. And I think, I think there's, maybe you're just sharing what you've done, Martin, but wow, it's really opens the thinking about what's possible, I think.
I think it raises the possibility that maybe we could do some of these that aren't expressly on like code. Like, I mean, I always wanted there to be this aspect of it, of people explaining what they did, so that it would have some tangibility, some realness to it. But like motivational theory or some of these other things, they could be discussed without that, and maybe that, I don't know if other people are looking into, have been reading about that or interested in that. I would open the door to anybody that, like, for example, I'll just give an example of Marvin Minsky's book, Society of Mind. Has anybody seen that? Or it's a really interesting book of a bunch of essays. And like I found with it, even just taking like just a few pages of that or a paragraph of that and trying to digest it led to like so many thoughts, like just would page after page would blow my mind. And so that would be something if some other people in the group wanted to take on that or some other text and just presenting a subset of that to spur ideas, because it's relevant regardless of whether anybody like, that topic and other topics, regardless of whether they built something with it. I still think it's something that we could cover.
Yeah.
Not everybody has the time to go, spend programming as much
No.
as I do, I'm sure.
I think your question though here, geez, we're way over. Sorry, Thomas and everybody else, but I think your question here was really about are we going in the right direction with the group? Man, this is really eye-opening stuff. I mean, most of the material here is kind of at the wow level for me anyway. You know, to
too.
think about, well, somebody's attempting to implement this stuff or has done it already in these different ways. I mean, all very new stuff to me. So, I mean, it's really impressive that way. And like I said, don't really have anything to contribute here, but I'm getting a lot out of it. So I really appreciate the format and what's being talked about here. I don't think it's I think it's very productive that way. Yeah,
Okay, well,
I'll let somebody
good.
else
Yeah,
speak.
I think it'll continue to evolve, and I think if anybody has any feedback at any point in time, I would welcome it. But I'm glad that people, that people are getting something out of it. I enjoy it as well, and am getting something. It blew my mind the night, for example, not to run us too long, Thomas, but the ramifications of like Chat GPT and an ability to like explain something like a 7th grader or like those other things. And I'm like, I still can't process that. I know it means something big. I just don't know what it is.
Mm-hmm.
And
But it has
I
to
got
have
that.
glue, but it has to have glue around it, like you're discussing here. Like this is what's going to make it things like that super useful, right? It's the glue and the other aspects of it which you're explaining, exploring, doing, which tie right into that. I think we should have had this conversation 2 hours ago, maybe. But
Yeah.
sorry, Thomas.
All right, guys, it's about that time. We're gonna close it down. Hate to be that guy, but I'm assigned to be that guy. So
Okay.
because I'm that guy. I'm that guy. So
Yeah.
thank you, everyone, for coming. I really appreciate Camp and all his help. If we want to talk more about going into a weekly program, let's discuss that offline. We need to discuss that between Martin and Camp and myself. It sounds like a lot of the members would like to come more than twice a month. So we could try that. We could pilot that and see how well that works.
And a last thought on that, but we've had some people that keep asking if there's any way to get something in an earlier time zone occasionally. If there is any way to facilitate that, it would be nice, because we lost some people. We lost some central time zone people, I think, from Suresh has got a hand symbol on him.
Last question. So if you can kindly share this video recording or whatever video recording you have of this wig, that'll be awesome. And one request to Martin is
I'm shutting off the recorder now.
Yeah,